It's 6 o'clock, so we're gonna start this workshop tonight. Welcome to the final workshop of the Soil Fertility and Nutrient Management series. Thank you for participating with us, whether this is your first or your third workshop that you've attended virtually. We hope these have been enjoyable, and we hope that you take some of the ideas from this to apply to your farm. As always, make sure that your video and audio are muted. And if you have technical issues, please use the chat box, which is near the bottom of your screen, and let us know and we can help you out. Also, please make sure that your name as the participant is your actual first and last name. That makes it helpful for us for attendance reasons. Also, at the end of each speaker's presentation, we will have a question and answer time. So you are able to unmute yourself so you can ask your questions verbally, or you can also use the chat box. Or if you want to raise your hand before you turn on your audio, we can do that as well if we have a lot of questions. If you are here for credits, if you are for commercial applicators, please use your chat box, and where it says everyone to everyone, there'll be a drop down bar there and you can select Lindsay Bloom. That's who you will message with your first and last name and your number. And then for private applicators, you'll select Brad Colhagen. So yeah, if you're here for credits, please message them in the chat box privately. So tonight, we will begin with Jamie Boltmeyer of A&L Great Lakes Laboratories, and he'll be speaking on the topic of interpreting a soil test. And then we'll have Lindsay Bloom of ISDA, who will facilitate our question and answer portions, and Brad Colhagen of Adams County Purdue Extension will present our PARP topic. So yeah, thank you so much for attending. Jamie, if you'll begin here soon.
Making you nervous, wasn't I, Katie? I just found a quick change I need to make in the presentation, so I was zooming through that quickly to get it done before we started. Welcome everybody this evening. I'm Jamie Boltmeyer, joining you from A&L Great Lakes Laboratories in Fort Wayne, Indiana. It's a bit quieter around the lab here. Sort of the calm before the storm. We see that crop production is speeding readily through harvest, and suspect we're going to have an earlier fall than we've had the last couple of years. So we're in the final stages of preparing to gear up for our major season coming up here, where we'll start running somewhere between 12 to 15,000 samples daily through the laboratory, 5 days a week, and then sometimes we'll go into 6 if needed. So let's go ahead and get started. What I'm going to do is I'm going to just make sure that everybody's up to speed. So I'm going to do just a brief introduction, just in case we have somebody that did not join us in the last two. If you haven't, welcome. If you had, good to see you back. And we'll get started here. So again, I'm Jamie Boltmeyer. I am a certified crop advisor, a certified professional agronomist, as well as a nutrient management specialist here with A&L Great Lakes Laboratories. I cover northern Indiana and Ohio as my primary sales area, but I'm also the sales manager for the entire organization. Give you a little bit of background to make sure you have an idea of where my comments are coming from. Most of my experience, while rooted in academic, is production ag based. So a little bit of background, I started out my agronomy journey actually in FFA as a Future Farmer of America agronomy contest, and now career development event lead judge. Actually, Brad Colhagen will be presenting tonight. He and I competed together, and that's how we met. Originally was in FFA in the agronomy contest, getting those fundamentals of fertility in our educational experience. But I found something I liked, and I went on to do my undergraduate at Purdue in crop and soil science. Wasn't the greatest time in agriculture to get out, and I thought I want to do a little bit more. So I stayed on at Purdue and got my master's degree in soil fertility and weed science, looking at how soil pH impacts pre-emergence herbicide control, which a lot of that work had been done, but we tied that to weed growth. And we actually found that some weeds actually grow much better at rather odd pHs, which made controlling them more difficult, even though that was a pH that necessarily impacted the herbicide. It was an interesting study. Had a chance once I got out of there to get into ag retail. I spent 2 years with Champaign Landmark Cooperative, salesman. I did everywhere from unload grain, drive train, run floater truck, deliver seed, sell seed. And it was a great experience to see what's on the other side of the counter in ag retail facility. That's now part of the Heritage Cooperative program. As a farm boy, I thought I knew what happened at an ag retail / co-op, and it's a different world on the other side of that counter. And there's a lot of things that pull those individuals in a lot of different directions. It was a great experience. And I carried that experience into John Deere and actually focused on precision ag, so, and how that related to soil fertility, soil physical properties, for commercial application equipment, guidance. Self-steering was big, and so section control was big when I was working with John Deere. Wonderful company, really enjoyed my time there, but it was a pretty big drain. Spent a lot of time traveling, and my real passion was agriculture. And at the same time I was finishing up my tour of duty there with John Deere, my wife Tracy and I decided, hey, let's jump into farming in 2012. It's something we've been preparing for, saving money for, working for, and we actually bought our first farm in 2012. And you see the picture down in the lower left-hand corner. We farmed just north of the Adams-Allen County line, and that's really where my passion in lies, is that production agricultural segment. And luckily I found an opportunity here with A&L Great Lakes to tie those together and be able to work more on the production side rather than traveling the Northeast US for a larger corporation. So it's a great fit, and I get to do opportunities like this. So a little bit of background. So most of my comments will be more production based rather than academic. What we've sort of covered here, so up to this date, is the first meeting we looked at some basic soil properties, and we'll revisit a little bit of that as we go through this interpretation. The second time meeting was how to get a good sample and how soil sampling fits in. I want to review just a little bit of that before we get started with the actual data. One thing you keep in mind is when we look at the soil test report, and hopefully you had a chance to get a copy of that ahead of time. I'm going to pop it up here on the screen just quickly. And this is a traditional A&L Great Lakes soil test report that'll look slightly different, come from different labs, but it has the same basic information. The thing you need to really understand is the organic matter and the pH are actual definitive measurements. They are no different than taking a tape measure and measuring a board that is 12 inches. It is 12 inches. When we get into the nutrients, it's more of an index. It is not an actual. It is not a total. And we'll talk about that just momentarily. So in and of itself, organic matter is a definitive number. pH is a definitive number. But the nutrients are actually a bit more ambiguous in that they really are what we call an index. As long as we can take that piece of information and tie it to something, such as a fertilizer recommendation, then that number has meaning. In and of itself, it doesn't. So for example, when we measure phosphorus in a soil sample, we're actually only measuring approximately 3% of the total phosphorus in the soil. So with that, let me come back to my main presentation. So we're only looking at maybe 3 to 5%. So we never look at the totals when it comes to nutrients, because the majority of them we can't access, the plants can't access, and they're not of benefit to us in the program. Now we need to be conscious of it, and they can have secondary impacts, but for traditional fertility programs, it really doesn't have a big play. So when we say extractable phosphorus, extractable potassium, what that means is we are pulling out everything that's in the soil solution. That's the water fraction in the soil that has dissolved nutrients in it. That is the water the plants are taking up and actually absorbing those nutrients from in most cases. It is on what's the exchange sites, and we've talked the last 2 sessions about cation exchange capacity, and we'll talk about it as the report. Those cations that are absorbed or held tightly by the soil, we will extract those. These are weak acids, and we'll get a small fraction of what's non-plant available. So the first 2 are plant available, the third one isn't. But what this does is it mimics and gives us an indication or an index of what portion of that nutrient in the soil is plant available. And what's really key to these soil tests is that while it's not a definitive amount, they need to be repeatable. If I take a sample and I run the phosphorus test 5 times, I should get the same number each time. If I run different soils, I should get fairly similar numbers. And that's why we need these extractants over time, and these processes have been developed so they work over a wide range of soils and they're repeatable. Then we can say, hey, this a soil at 15 part per million phosphorus should not need any more fertilizer. It has enough. Well, therefore, if my soil test says I have 15, we know what the answer is and we know how much fertilizer to apply. So that's the key, is we have to be able to tie the soil test data to an interpretation or to a recommendation. And that's what I'll spend my time here this evening, giving a feel what normal numbers look like, what these nutrients do, and a little bit of those key facts when we looked in that soil test report. So what I'm going to do is, if you printed off that soil test report, I'm going to start on the left-hand side and work column by column through it and give you a little bit more detail about the backgrounds on each of those items. So what I like to do is, a lot of times, again, just to prove that, to not prove, but to show that point, here's a good analogy. When we're looking at our nutrients, not our phosphorus, not our pH or organic matter, but our nutrients, they're sort of like a gas tank on our vehicle, on our tractors, on our trucks. We have a definitive amount of liquid in that tank, but we use a float, we use some kind of measuring device to give us an indication, because we don't want that fuel tank to run off empty. So we're going to give ourselves a little bit of information. So inside that fuel tank, there's going to be a float, and I'll highlight it here. That float floats on the liquid. If it's halfway from top to bottom, all of a sudden our gas gauge at the top shows half full. That gas gauge is really our soil test. It's an indication, it's an index of how much is in that gas tank, but it's not an absolute measure. It doesn't say there's 7.38 gallons. Now, some of the new vehicles get a little closer to that, but I think you get to the point that as long as we trust that fuel gauge, we can work with the amount of fuel in the tank or what our fertility is in the soil profile. So let's get started, and we'll start on we'll just go ahead and start on the left-hand side. The first column you come up to is organic matter. And this is one that's gained a lot of interest. There's been a lot of concern that organic matter levels have been declining. We've been consuming or decomposing more than we have been building. That has been the case, but you can see and I'll show you some data here if we have time at the end. As a whole, that decline has stabilized. Now, granted, that decline's been going on a lot longer. My data only goes, that I can show you, the data only goes back to 1996, so 24 years. It's been going on longer than that, but we can actually see a stop and a reversion taking place in general. Now, it's probably a little late and we can help it along, but the positive news is the message is getting out and things are changing. The thing with that organic matter is you only have one number, and that reflects all the fractions of organic matter. And how that measurement's actually taken is we take a sample, a sub-scoop of your sample, and we weigh it. We get a definitive measurement of weight. We put it in the oven, and we take it up to 800 degrees Fahrenheit, and we burn the organic material off, and we hold it there for a certain, I think it's just shy of 3 hours. And then we cool it back off to a standardized temperature. We weigh it again. It's a loss of weight. It's called loss on ignition. It's not the most standardized way to do it in the industry. There are some ways you can do it with visual color charts, wet chemistry. Most of your large production ag laboratories are using loss on ignition because it's efficient, accurate, repeatable, and it fits in a production cycle. It does take some time, but you can build it into almost a assembly line methodology. So with organic matter, the key is hey, it is a great piece of information. It is something we want to build. It is a measurement of the plant and animal residues left in the plant that are helping improve soil structure, water infiltration. It is a source of nutrients. But a lot of times people ask us, what is a good organic matter level? Well, or what is the ideal organic matter level? Quite frankly, any organic matter improvement is the key. The amount of organic matter in a soil is going to depend a lot on how that soil was originally formed. You have soils that are sandy or soils that were developed under forests. They had less organic matter to start with than a prairie soil or a true completely organic muck. A lot of people call their heavy clays mucks, but true mucks are all organic matter. They're peat. They will burn. It's not heavy clay. So sandy soils usually start in this region at about 0.5 to 2%. You will find some things called black sands. They're high organic sands. They're uncommon, but there are pockets west of Fort Wayne. You have forested soils so what Adams and Allen County are. Those are going to be 2 to 4% organic matter natively, as well under good management. Now, if you go down towards Lafayette, you get into Illinois, you'll get into those black prairie soils. And when you get over about 4 to 6% organic matter, the soil physically looks black. And then muck soils are over 20% organic. Almost, they behave a little bit different than our, what we call the top 3 are mineral soils. One thing to keep in mind is about 11 to 22 pounds of nitrogen per acre. Oh, I see. I missed one of my edits there. Sorry about that. That was one of my catches. I was doing this for a long master gardener and everything was in square feet. But 11 to 22 pounds of nitrogen per acre are released for every 1% organic matter. And that's not because we're burning them off. That's just normal cycling of nutrients in the organic matter. We need some of that. If we don't cycle some of those nutrients, the organic matter can actually build up too thick, especially in continuous corn, that we can't actually farm it effectively. You'll have too thick of a trash layer to work with, or residue layer. And that's also why in central Illinois, it's hard for them to determine what their optimum nitrogen rate for corn is. If you have 6% organic matter, you could get as much as 120 to 130 units of N just from your organic matter without the first bit of additional fertilizers or side dress. So it does make it a challenge for the central Illinois farmers to dial that rate in, because they could get 60 pounds, they could get 120, 130. Weather will only tell. So if we look at that organic fraction, it's going to include the fresh residue. That is the stuff from this season. It's going to have the living organisms in it. That's all going to be in that number. You're going to have the decomposing material, and that's the stuff from maybe the last 3 or 4 or 5 seasons. It's mostly decomposed. You can still maybe identify it, but it's unstable. We're still rapidly breaking down. And then you have that stable long-term, that stabilized organic matter, humus down in that lower left. That's what has an impact in soil quality. And a lot of times we'll see folks come in, ooh, I increased my organic matter by 1%, 2% this year. That's not practical. I would assume in most of those cases that the majority of that is fresh residue or residue from the last 3 or 4 years. That's not the stable. In most cases, we can effectively add about 1/10 of 1%. Again, this is by weight. So organic material is much lighter than mineral soil. So if we can add 1/10 of 1% of organic matter on an annual basis, you're doing a very good job with your cover crops, with your conventional reduced tillage, no-till, what have you. That's about as good as can be done, and that's been documented several times here in the last couple of years. So now we get into the nutrients. There's a concept I want to cover before we get into the details, because it'll help you understand what we call sort of target critical levels, sort of those ideal levels that we're aiming for. And so I'm going to use phosphorus as an example. This is one of the cleaner data sets. But on what I have in this particular piece, it's actually from Dr. Malorino at the University of Iowa. I think he was at Illinois at the time he did this. But what we've got is a data set, and this is really no different than what Purdue has for the tri-states, which we'll talk a little bit about. Those have been released, but they're not completely public just yet. They're in that process of releasing. But down across the bottom of the soil test, we'll have the actual soil test levels. Those are the numbers from your soil test. This is what's called Malic 3. It's a different acid used to pull that extractable fraction out. It's a little stronger than what we have traditionally used, which is Bray. That's what's on your soil test report. That's what the current to past tri-state was. Moving to the future, we'll go to Malic. It's going to increase the numbers a little, but the concept works the same. And then on this axis, we have yield. So the point I want to get at is often people look at this chart and they think, oh, that if I put on more fertilizer, I will get more yield. And that's not quite the case in all situations. You also hear people say, well, I put fertilizer on and saw no response, so I'll never do it again. Here's the sort of the backstory. So I bring this arc up. That is if I just drew a nice clean line through the data. You see how it makes a real sharp, it climbs really quickly through that 10 to 20 mark and then takes a really narrow curve once we get up above 30 to 40. But let's back and look at the raw data. A lot of times, whoops, going the wrong way. A lot of people look at that curve, but let's look at the raw data. What it really comes down to is as my soil test increases, the chances of a bad yield are reduced. So if you really look at it, in a lot of cases, no matter, my top end yield here is roughly 105% of average at all soil test levels. But if you notice, there's a good chance that if my soil test levels are low, it could be anywhere from 60% of yield of average to over average yield. As I come into what we call the critical level, look at how that yield range decreases. So in a lot of cases, as we improve our soil fertility, we actually reduce the risk of having a bad yield. I've got some land that's not the best stuff, and that's the reason I could afford it. I've probably mentioned that in a couple of the other meetings. What comes down to is it was single-digit phosphorus. We were down at that bottom end. And I raised 200 bushel corn. I've raised 140 bushel corn in that same field. It depends on weather conditions. When the stars align, we're fine. But when when the weather conditions are tough, that's when those poor fertility programs come in and really show you what your opportunities are. So when we look at this, we're often looking at what we call a the term that Purdue uses is critical level, but it could be ideal level, could be target. And I'm going to use the university recommendation structure. There are numerous ones out there. I'll stick with the university one. It's probably the cleanest, and most of them are very similar in design. So that sort of gets us an idea. So our critical level, when we look at that curve, pops in right at that, oh, quit going backwards there, right about that 20 to 25 part per million malic. And lo and behold, the new corn tri-state recommendations will be 20 part per million malic. So basically below that mark, we have a lot of risk for low yields. We have a lot of yield variability possibility, and there's a good probability that our crop will respond to additional fertilizer. When we're above that 20 mark to 30 mark, the probability of us seeing a yield response to fertilizer significantly reduces. And in that case, we don't try to go any higher. We just simply try to maintain. And that's the fundamentals of these recommendations. And I'll give you what these critical levels and sort of what that normal range looks like. So the general model here is if I, at my critical level, and I've got that marked here, if I am below my critical level, and you see the red line is my fertilizer application, I'm actually going to put more on the lower my soil tests are, in goal of getting up to that critical level. And if you look at a lot of the recommendations, it's actually designed to go from where you are to that critical level in a set period of time. The math is lined out. I won't get into that detail. It's probably a little beyond today's conversation, but if you would like to, we can definitely talk at another time. So if I'm below the critical level, I'm going to build my soil up, and I'm going to try to take advantage of those opportunities of increased yield in tough situations by putting a little more on. But once I get above that critical level, there's really no agronomic benefit to having more. I'm not going to see a lot of return on my investment. And so in that maintenance range, we simply put on enough fertilizer to keep it steady. Then we get to a maintenance limit. At some point in the majority of this this line is arbitrary. The maintenance limit is academic guess, but it's a safety point where they say, hey, at above that, we really should probably put on a little less fertilizer and bring it down even more. Let's bring those soil test levels down. And how that's done is this magic dotted line. That is what we call maintenance fertilizer. So if I take the yield times a crop removal factor, how much PK is in that grain or that forage I'm removing from the field. If I put on enough fertilizer to replace that crop removal, you might have heard that term, my fertility level should stay steady. It should not go up or go down if I do my math and my management correctly. So if you notice here, when I'm in buildup, I'll actually put on what the crop removes plus a build factor. And then when I go to drawdown, I'll actually put on a little bit less than crop removal. I'll take crop removal minus some until I get out to a point where I actually stop putting fertilizer on. And so that maintenance range is usually what you see in your soil test as a medium, is a ballpark, that sweet spot per se. So some things, I mentioned the tri-state, a couple of big things that if you're following fertilizer recommendations, they are changing lab chemistry. So we're going from malic to malic from this bray and ammonium. Bray and ammonium are the traditional ways of measuring these nutrients. It's the liquid we put with the soil to pull that extractable amount out. We're going to malic 3, and this is actually a great thing. We have been malic 3 since 1991 and calculating the data backwards. It's going to reduce the lab-to-lab variability. It's going to match most of the university research across the country. It's going to keep up with some of the other regions in the US. And it's actually a very good thing, but it will create some different numbers we'll have to get accustomed to. The other thing they did in the tri-state, they actually removed that drawdown portion of that equation. That's okay for phosphorus, but potassium is a little bit different. We'll talk about that when we get to potassium. In order to combat that, they move that maintenance limit up. And sometimes when you fall off that cliff after the maintenance level, we can see some real quick declines in soil fertility. We'll talk about in phosphorus and potassium a little bit. And they adjusted how much nutrient each bushel or each ton of crop remove based on some new data. So what you'll find, the phosphorus critical level didn't change. The potassium critical level is very similar, just a little wider maintenance range. So not a lot of big changes. I think it's actually very positive to show that what we've been doing in the university level for some time has actually been correct. So, okay, let's get into the nutrients a little bit. So now we got some of the background. We'll get into phosphorus here. So what does phosphorus do in the plant? It is a major component of adenosine triphosphate and diphosphate. You don't need to know a whole lot about that chemical structure other than it contains 2 or 3 phosphates. That is what we use as an energy source around the plant. So we'll actually take an adenosine 2 phosphates, and in photosynthesis, we'll actually add a 3rd phosphate onto it, and that will pend up some energy. Then we move that molecule to the growing point of the plant, usually used at nighttime, and we cleave or take that phosphorus off. So it transported the phosphorus to the growing point, and when it removed, it released that energy that's used to build components. The diphosphate's taken back to the leaf, the phosphate is added, and that cycle continues. It is an elemental structure of RNA and DNA. So what you'll find is phosphorus in the plant, it doesn't take a lot, but it has very important roles. Sort of what we see the environmental. It's very reactive in soils. A little bit goes a long ways, but it's critical and important to have. So without it, we don't have RNA and DNA development. So as you can see here, plants that are phosphorus deficiency have a tendency to lack energy and struggle to grow. It's an essential component of all cell membranes. Cell membranes are fatty acids. They're water, they prevent water pass through them. And so they're long chain phosphorus fatty acids. So again, the cell wall is a relatively small component of the cell as a whole. There's only a little bit of phosphorus in that cell wall, but it maintains a pretty critical function and is definitely, again, going to limit plant growth when not available. Supports early season root development. A lot of it has to do with that easy root cell division and growth. One key thing about phosphorus is it takes about 18 to 22 pounds of P2O5 application to raise your soil test 1 part per million Bray. So a part of that soil building process is I can basically calculate my soil test is here, I need to go here, that times in the university tri-states, 20 is how much phosphorus I need to apply to raise my soil test to that target. Now, I don't want to do that in all 1 year. The university guidelines break it down into 4 years. So you take that amount, divide by 4, and that's what starts building some of those nutrient recommendations. Another little mistake there. Please ignore my 6 to 8 pounds. That's where I got an edit there. It is 18 to 22 pounds for 1 part per million. Phosphorus is negatively charged. It's not held by the CEC, but it's highly reactive with positive cations like calcium and magnesium. And that's how we hold it into the soil profile. It does require the residue, since a lot of that phosphorus is in things like cell walls. We need that cell wall to decompose to get that phosphorus back for the coming season. So we do want to see some of that decomposition of organic material so that we can cycle that phosphorus for future crops. Now, some soil test numbers. Let's get into the numbers on your soil test report. If you have a soil test level above 100 part per million Bray, that's sort of the critical level for leaching. You start seeing in nutrient management plans, if any of you are doing 590 manure plans, you'll see 100 is sort of a critical number to 150. Those are benchmark numbers between 100 and 150 that if I put more phosphorus on the soil and my soil test is that high, there's a good chance my soil cannot hold on to it. We get much above that and the concentration of phosphorus gets high enough that we can actually see it leach like nitrogen out of the profile. So that's why we don't want really high soil test levels. But what are some decent numbers? I've sort of pointed them out. And again, I'm going to go the old tri-state since the new ones aren't completely out, and we're going to talk Bray. 15 part per million Bray is that critical level. If I'm below that, I need to build up. If I'm above it, I maintain. 15 to 30 is that maintenance range. So that's really where I'm just going to put on crop removal. That's sort of the sweet spot. And if I'm 30 to 40, I'm going to draw down. Now, we might see some agronomists say, I like to be between 20 and 40 is my crop removal range. Yes, they're not necessarily university guidelines, but they're within reason. What we want to avoid is those 80, 100 part per million recommendations. When we get to 40 part per million Bray, in corn and soybeans, we actually go to no application. So it doesn't take a whole lot. If you look at that soil test that I provided to you, most of those are actually borderline deficient other than the silt loam there in the middle on page 2. So it just gives you some numbers to work with. Quite frankly, I've got some customers that'll show you that once you get over about 40 to 50 part per million Bray, you can actually see some yield reductions rather than yield increases. So there's really no reason agronomically or environmentally to maintain anything close to where that leaching potential would come into play. You will see some popular press, like I pick on the Hefty brothers from time to time. They start at 100 and work up. I don't recommend following that recommendation. So how phosphorus works is, I like this from Dr. Basta at Ohio State University. The concept is what you'll find with phosphorus is there's an absorption capacity there. When the soil test levels are very low, that soil is hungry for it. It will react and it holds onto it very tightly. And as we build our soil test levels up, especially we go into the 30s, 40s, and 50s, the plant, the soil begins to release some. So it's sort of like Dixie cups here, solo cups. We've got a few holes at the bottom, but you notice there's more holes at the top. So as we start putting phosphates in here or a liquid, we'll think as an example, we want to get enough in there so some spills out. We need some spill out so that the plants have availability. So what we're doing in a lot of cases in our phosphorus management is how much do we need to put to get enough spill out to control plants, to provide nutrition for plants, but control it to the point that we don't have environmental loss. In a lot of cases, you'll find that that is right in that nutrient management range, usually just a little bit higher than we need for good crop management. And you will usually see, because clays are where most of that phosphorus is absorbed, it's easier to build the soil test levels of sands easier than clays. And that's the challenge is we can't predict this. We don't have a good way in the industry to predict it, but we can use routine soil testing as a feedback to tell us when we've gone too far and start slowing ourselves down and even taking ourselves to zero application if we follow the recommendations. So here we'll get to potassium, and here's where I failed to edit correctly, and my apologies. The key fact should say it takes 6 to 8 pounds of K2O per acre to raise it 1 part per million. I just realized before I got started, I used this presentation for a master gardener group last, and we were working on a little different scale. So 6 to 8 pounds of K2O per acre to raise it 1 part per million. Potassium is doesn't get used by the plant. It is a tool. It's almost like a lubricant, you might say. It doesn't get incorporated into individual components, but it helps everything to move easier, for things to work smoother. So that adenosine triphosphate, the production of that initial molecule is sped up with adequate potassium. There's over 60 photosynthetic enzymes that can include or work better with potassium involved. You'll find that potassium really helps with stressful environments, especially times of too much water or too little. Times of heavy disease pressures usually allow plants to survive those environments much better than without. I'd argue if you look at some of the corn around the Northeast Indiana area that is suffering from drought, part of it's probably due to low potassium levels, and the other part is probably due to soil compaction. But a lot of times those go hand in hand, unfortunately. Some other key enzymes: starch synthesis. Corn grain is mostly starch. We see higher yields predominantly through potassium fertilization through that manner. Also, nitrogen metabolism and use is more efficient. So usually plant health comes in from potassium. Potassium is easy to move through the plant. You can create concentration gradients that a plant can put a little potassium right at the very outside of a root cell, a root, and actually cause a concentration gradient that will actually pull water in stronger than if it wasn't there. It also regulates transpiration rates and quickly adjusts transpiration rates in very tough times. When the plants start curling, when corn plants start curling and turn into that pineapple appearance in droughty conditions, that's a time when potassium will really shine and help you control that water loss. You can actually close the stomates under the bottom of the leaves tighter with adequate potassium fertilization. If you haven't gotten the gist of it yet, I am a huge fan of potassium management. I think, quite frankly, keep the phosphorus at a low level and focus on your potassium if you're looking for yield, which is a little bit contradictory in the industry. It is a positively charged cation, so it's held by the soil. And again, remember that key factor should be 6 to 8 pounds of K2O per 1 part per million. So I apologize again for that error. It is not incorporated in plant structure, so we get it back quickly, so we don't need the decomposition of plant residues. As soon as soybeans start turning yellow, you might have some soybeans turning yellow in your crop fields right now. Potassium is leaking out of those plants as we speak. 80% of the potassium will be returned to the soil after a soybean crop within about 4 weeks. We have 95% back by the following growing season after soybeans. One thing about potassium is plants luxury consume it. Soybeans will take up to 50% more than they need just because it's there. Hold it for a rainy day. Corn is 60 to 70% more than it needs. Alfalfa can double its uptake. So alfalfa is one of the crops, when we start looking at alfalfa in corn silage, we do want to manage our potassium a little tighter because we don't want to overfeed that crop. It's simply going to leave the field in that stover with little benefit to the livestock consuming it and at the detriment of the soil fertility. So what are some normal numbers? Now, the critical or target levels of potassium are based traditionally on the cation exchange capacity of the soil. The higher the cation exchange capacity, the tighter this is held onto, and the more we need to apply to get that release, sort of like that phosphorus solo cup I shared with you a little bit earlier. But this is a general number set for the soil test you have in front of you for Northeast Indiana, for the Blount Pewamoos, the Lenawee silt loams, and those kind of things we see in the region that usually have cation exchange capacities in the low teens. This is the kind of numbers we're looking for. 100 is that critical level, that target. So below 100, we're looking to build up or to increase. Now, sandy soils, we might be a little bit lower than that. 100 to 130 is sort of that sweet spot where we just simply maintain. And about 100 to 150 is when we start saying, hey, we've got enough, we need to put a little less on. We get over 150, 170, we have more than adequate, and we can actually go without any application or a very light maintenance at most. So in a lot of cases, when folks start looking at tough economic times, I encourage you to look at soil sampling. If you have some fields that are high in phosphorus or potassium, you've got a perfect opportunity to cut back that fertilizer rate and gain both the environmental impact as well as the financial improvement from those opportunities. Potassium is a little bit of an unusual thing to manage. It will vary quite a bit in soil test levels. Only about 2 to 2.5% of potassium is plant available. But there's a 10% pie wedge there, and that will become available if the weather conditions are right and the stars align. Potassium is weakly held by the soil, and if you notice, it only took 6 to 8 pounds to increase it 1 part per million, where phosphorus was 18 to 22. Potassium will build quicker. It will draw down quicker. So if I mentioned before, if I go to and glop that drawdown portion of my fertilizer recommendation off and go over that cliff and go from full rate to crop removal to 0, I can see my soil test potassium levels decrease greatly. I had a software issue on my farm where I worked with a software company and we both made a mistake and didn't catch it, and we lobbed that drawdown off of the recommendation structure. I dropped my soil test potassium 40 parts per million in 1 growing season. I went from drawdown, putting less than crop removal on, to having to build it back up in 1 growing season. So it can change quickly. But that 10%, if we are in extended periods of wet weather, if we have lots of freeze and thaw, we can actually obtain a good fraction of that 10%. That's also why in a lot of cases our potassium soil test levels are higher in the spring. Now, it may only be 5 to 10% higher, but they are higher. We've gone through a period of wet weather, usually in the winter. We've had freeze and thaw. We've had release from crop residues back into the soil profile. And we usually see soil test levels higher in the spring than in the fall. And then they'll decline through the growing season and be at their valley right about harvest each year. So right now is when we're going to see the lowest soil test potassium if we check it on a regular basis. So we'll move on out of potassium into magnesium. Magnesium is usually provided to the soil. We have a lot of magnesium naturally, but it's also provided through our liming materials. Lime usually has a magnesium component in our region, and it's important. Some people really try to reduce the magnesium application and almost treat it as if it's evil. We've got to be careful. We do need it. It's a central atom of chlorophyll. Pretty important. Without magnesium, we don't have chlorophyll. That's the entire plant factory. Deficiencies are most common on sandy soils. You can't hold on to it. We don't apply as much lime to sandy soils to maintain pH. Because it comes in lime, it's usually most common in low soil pHs. But this is important for our livestock growers out there. When we get below about 100 to 120 part per million magnesium, we actually can induce what's called grass tetany. We can actually cause a deficiency of magnesium in the livestock's diet that can lead to the staggers and ultimately death. And so a lot of cases we run into situations where livestock producers are trying to improve a drainage on their pastures, and they're trying to manage that magnesium level. And we can actually create ourselves a very dangerous situation if we're not paying attention. So like a lot of things in soil science and in soil fertility, we have to look at the balance that works between them. Pardon me, I'll back into there. Magnesium, again, anything over 100 to 120 is adequate in a part per million basis. Calcium, this we don't fertilize for. Actually, magnesium and calcium are referred to as secondary nutrients. N, P, and K are primary, most likely deficient, needed in largest quantities. Calcium and magnesium, we use large quantities of them, but very rarely do we need to fertilize. You will find some cases in vegetable crops where we need to add supplemental calcium to get good fruit quality. Watermelons will get blossom end rot if the vine grows too quickly and produces that melon without enough calcium. But it will enhance the uptake of nitrates, pretty important. It regulates K and sodium uptake. With good calcium fertilization, the plant will prefer taking up potassium over sodium. Not a big issue in our area. We don't have a lot of sodium, but sodium is actually toxic to plants. So good calcium management has a good impact. It has a key impact, like in the Western Plains, for example. It's mostly taken up by our young root tips because there's about 600% more calcium in the soil than the plants need in most cases. So a lot of calcium is simply taken up by roots growing to it. And a lot, when we'll look at potassium and phosphorus, those are usually brought to the plant through diffusion, and roots explore soil, but they don't grow to the nutrients. Roots happen to proliferate where the nutrients are present. So you'll see more roots where the phosphorus zone is. They didn't grow there, they just responded when they found it. So proper pH management usually handles your calcium needs. But calcium is going to vary widely depending on what kind of soil. A sandy soil, 500 to 1,000 part per million is more than adequate. Loams, silt loams, like we deal with most of the time, 1,000 to 2,500. Clay loams and pure clays, which we don't see a lot of in this region. I know we have clay soils, but not a lot of pure clays, upwards as high as 4,000. A lot of times, folks will talk about the base saturation of calcium. If you look at our soil test, that's off to the right. What that does is that allows us to take a sandy soil and a silt loam soil and compare them. So for example, a properly pH, properly managed sand soil might have 750 part per million calcium, and 65% of its cation exchange capacity, or the cation load that it carries, is occupied or is present in the calcium. A silt loam might have 2-3 times as much calcium as parts per million, but still have the same ratio in that cation exchange capacity. It may still be 65%, so we could say both those soils are the same in calcium producing or calcium supplying power. So that's where base saturation comes into play. It allows us to compare the cations of dissimilar soils. Same with potassium and magnesium. So getting into pH, and this is where I think a lot of management needs to start. pH impacts the form and availability of all the nutrients on the soil test report. So if we don't have this right, we're struggling with everything else other than even organic matter, but even it can impact organic matter as well, and its buildup or drawdown. So pH is actually a measurement of the amount of hydrogen in the soil, and it is logarithmic. The lower we go down the scale, it's like the Richter scale, the lower we go down, the more acidity we have, the higher the hydrogen concentration is. So for example, 7 is neutral. We're neither acid or basic. As I go down, I increase the amount of hydrogen in the system. I increase my acidity. My pH value goes down. Every step is 10 times more acidic than the next. So a soil that has a pH of 6 is 10 times more acidic than a soil with a 7. A soil with a 5 is 100 times more acidic than a soil with a 7. A 4 is 1,000 times more acidic than a soil with a 7. So the longer we wait to correct soil pH, our targets of soil pH are 6.5. And this is the left-hand soil pH column. There's 2 pHs, and we'll talk about that in a moment. The soil pH target for corn and beans, wheat is 6.5. Forage legumes is 6.8. The closer you keep it to those targets, the less lime it takes to make an adjustment. So maybe if I have something in the low 6s, I need to put a ton on. I let that same soil get to a pH of 5, I might need 3 to 4 tons. I get down into a 4, I could be as much as 7 and 8 tons of lime. And so it becomes very difficult to correct these. And a pH in the mid 4s could be a 10 to 15 year correction process. We can only apply 2 to 3 tons in a given year in order to keep everything in balance. So with that being said, keeping your pH in check and frequent lime applications when needed are critical. We usually look at a lime application when the soil pH is 2 to 3 tenths below our target. So I cut that part of the soil test out, and I really want to spend just a couple minutes focusing on this. There's 2 columns. Soil pH, that is, if you look on the chart there to the left, soil pH is the managed value. That is the number we are managing. So when we say we want a target of 6.5, we want to see a 6.5, 6.5 in this column. This is the column we use for herbicide labels, for fertilizer applications, for all of our management. This is the management number. This is the soil solution. How we measure this is real simple. Deionized water, equal parts of soil, mix them and put a pH probe in it. That's what the plants are experiencing. It also be called the water pH or active pH or 1-to-1 water pH because of that methodology. It is 1 part water, 1 part soil. There's nothing real significant to it. Now we need good equipment to do this, and we want to follow laboratory procedure. It's pretty straightforward. It's probably the most simple process we do in the lab. Now the buffer pH is a little bit different, that right-hand column. We really pretty well ignore that right-hand column until we know we need to make a pH adjustment. So for example, that soil pH column, if I have a number that is 2 to 3 tenths below my target, so like that 6.2 there in line 3 is getting close, I might consider putting lime on that one. The top 2 lines, those samples need lime. When I make that decision to apply lime, I then look at the buffer pH. It tells me how much. The only time we use the buffer pH to determine how much lime to put on. Other than that, that column can be ignored. So I'll clear out my drawings here. It's a good thing I'm using the definitive shapes. I'm actually not that good of a drawer. Oops. And the reason we want to manage pH is this. Mineral soils, those are soils on the left that have less than 10% organic matter. If I look at the best possible plant availability, look what happens around my mid-6s. I catch the fattest part of each of those lines. I catch the maximum amount of availability of all those nutrients, but I don't get into the extremely high levels. If you notice, iron down here actually flares out at low pHs. Aluminum will do the same. those in zinc can at times, those metals can actually go toxic at low pHs, kill the plant, kill the root systems. So by keeping our pH in the middle, we avoid a lot of herbicide issues and things like that. We also get the maximum availability of the nutrients in that soil profile. If I go to an organic soil, those are ones with greater than 20% organic matter. We want to keep that in the mid fives to get that same environment, that same kind of situation. Because if I go clear back up, if I go clear up into the sixes, look at my micronutrients. They all but disappear. High pH organic soils are very difficult to manage. So getting back to the CEC, we've talked about it, and that's the thing with soil sampling and soil science is everything's interrelated. So we try to take a straight line, but I want to come back to the cation exchange capacity. It's on our soil test, and you saw this slide before if you were joined us for the first session. Organic matter and clay are our primary components that comprise cation exchange. Cation exchange is a negative charge on the edge or surface of soil particles that hold on to positively charged ions, cations, like potassium, ammonium, magnesium, calcium, a lot of those main nutrients. The ones we don't worry about leaching, the leachings are negatively charged and they repel. So how do we measure this? There actually is a method in the laboratory called ammonium saturation. It costs about $90 a sample. Any of you who pay for soil sampling probably aren't going to be real excited when your sampling crew comes out and say, it's going to cost you $8.35 to get that soil test in front of you, list price, and another $90 to get CEC. So what we do is we call CEC by summation. And so what we're going to do is we know that the cations that we see in the left-hand column make up the majority of the nutrients that are on that cation exchange. But calcium, magnesium, potassium, hydrogen, those top four are probably 95% of the CEC capacity. And so some scientists sat down and came up with a simplistic way to estimate CEC. And the thing with CEC is that you're probably going to manage a sample, a sandy soil with a CEC of 4, different than a heavy clay soil with a CEC of 15. We all know sand and clay soils, you treat them a little bit different, and that number reflects that. But if I have a 11.1 versus an 11.3 milliequivalents of charge per 100 grams of soil CEC. Yeah, a lot of people don't use the unit either. But that index really, that 2 to 3 tenths doesn't have an impact. And usually this method of estimating cation exchange capacity mathematically is usually within 2 to 3 tenths, unless we have some challenges. So what we do is we take the part per million calcium divided by 200. That's the milliequivalents of charge that calcium is occupying. Part per millions of magnesium divided by 120. That needs corrected as well. Part per million magnesium divided by 120 is a milliequivalent of charge occupied by magnesium. Potassium, 390. Sodium, if we test, is 230. Those are the main cations. We don't test for sodium routinely in our region because we don't have sources. We don't get it from our irrigation water. We don't get it from groundwater. It's not part of the parent material. We just don't have enough. It's negligible in 99% of the samples we run through the lab. Hydrogen is also positive charge, and so we use the buffer pH in a simple equation of 7 minus the buffer pH times 12, and we bring that hydrogen contribution in. We simply add all those milliequivalents up, we sum them, that total is the CEC. However, if you happen to print off the soil test report, you'll see that there's the last sample on page 2 is calcareous. It's a soil with a lot of calcium carbonate in it. That sample actually came from over by Plymouth, Indiana. And it shows 80.9 cation exchange capacity. That's not right. The soil has a pH of 8.2. There's naturally occurring calcium carbonate in that soil that caused the pH to climb high. It's stalled. It will not go above 8.2 with normal liming calcium carbonate. It is stable. It is stalled. It has 15,000 part per million calcium. So when I take 15,000 divided by 200, I overinflate that calcium contribution. The calcium's in the soil, it's just not on the CEC, it's unreacted. And so you'll see some unique situations where very low pH, very high pH, that can be a bit erroneous. But as long as we're managing our pH correctly, that estimation is usually within 1 to 2 tenths. And simply a mathematical calculation doesn't cost us $90 a sample. So sandy soils, below sands, are going to be about a CEC of 4. And the reason I put this chart up is when somebody calls the laboratory and says, hey, I have a question on a soil test. I can't see the soil. It's probably somewhere in the back of the lab with 80,000 of its friends. I can't see it. But I can look at the CEC and get an idea of what the soil is. If the cation exchange capacity calculation is standardized, is solid, I see a normal pH, not high or low. I can always tweak a little bit in my mind if need be. But if I see sub 4, I know I have below sand. I have white sand, coarse sand. It's not going to hold on to nutrients, and it's going to drain very well. If I have a 4 to 8, a upper level single digit, then I have a sandy loam. It has some organic matter, has some nutrient holding capacity, can hold some water, but still drains well. I go to a loam soil, 10 to 15, those are the good ones, and up to the lower teens, silt loam soils, clay loam soils. Those are the ones that can hold nutrients and can hold water. And that's most of our region. Sometimes they hold water a little too well, but they're serving us very well in these drier conditions we're seeing here the last couple of weeks. I saw 101 on the thermometer recorded at the Fort Wayne airport yesterday. That was a little disconcerting in August when we haven't had rain in 3 weeks. And then organic soils can be anywhere from 20, 30 up into the 50s and 60s. They can be just unbelievable. But those then, the organic matter holds onto the soil, the nutrients so well, the plants can't access it. So I want to get into some secondary nutrients. Got a little bit of time here and I want to get into these. Sulfur is one gaining interest. It has traditionally was called a secondary nutrient because we were getting enough sulfur from atmospheric pollution, the sulfuric acid rain, that we were getting 85 to 90% of what the crops needed through pollution. The Clean Air Act did it, and I'll show you some maps here in a second, did a wonderful job cleaning up the atmosphere, reduced that sulfuric acid in the rainwater, brought the pH up. It also reduced the sulfur our plants were receiving. We get about 15% or less of the sulfur it requires to grow national average corn or soybean crops each year. We need to supply about 75 to 80%. Sulfur is, and when it's in a sulfate or plant available form, is negatively charged and will leach. Some numbers to look at. If we're below 10 part per million, we need to basically throw the kitchen sink. We don't have, the soil doesn't have much ability to supply. We're getting sulfur from past crop residues, from manures, and we get about 1 to 3 pounds of sulfur for every 1 part per million of organic matter. We see some of that come released with the nitrogen when that decomposes. So below 10 single digits, we need to be aggressive in our sulfur management. We actually, for the first time, saw sulfur deficiencies in Northeast Indiana, something that's a rather record-breaking, unfortunately, not a good record. If we're in the mid-teens to upper teens, crop removal, or slightly less. When we're at single digits, I would put on here that we would want to apply crop uptake. So crop removal is how much nutrient a crop removes at harvest. However, we need enough to produce that crop. So if we're at single digits, I'd actually recommend sulfur complete crop uptake. That's all in the mid to low 30 pounds of sulfur per acre for a 200 bushel corn crop. Crop removal is more like 10 to 14, and that's if we're in single digits. If we're above 20 to 25, maybe a little bit in starter, a little bit foliar just to boost things will get us by. You'll hear the sulfur soil test start being beat on from time to time as it's not accurate. The challenge with sulfur soil test is only picks up sulfate, the plant available form. Most are fertilizers. A lot that will get applied are not sulfates. They're elemental sulfur, they're thiosols, and those don't show up until they convert to a sulfate that's plant available. So sometimes they can hide some of our sulfur sources. So this is what I wanted to show you. This is a timeline of slides that started in the mid-80s, and the red is high concentrations of sulfate. And as we go through the calendar times, you see that area of red declining. Most of that is due to the Clean Air Act. A lot of your industrial aspects of the U.S. were in the Great Lakes region and up through the New England states, and they were burning coal to make steel products, to generate electricity, so on and so forth. When they started scrubbing the sulfur using calcium carbonate to form gypsum calcium sulfate, they took it out of the pollution, they took it out of that smokestack outflow, and effectively by 2012, 2014, unfortunately that's where the map stopped that the NADP put together, it's virtually gone. And we started seeing nutrient deficiencies of sulfur perk up in the Corn Belt around 2014, 2015. It's a great show that the Clean Air Act worked, but there is ramifications of it. So now we need to look at providing that nutrient source to our crops. Zinc is another one sort of key for corn. The key part of RNA, that's the version of DNA that actually goes out and makes proteins and makes protein synthesis happen. So like phosphorus, it's sort of a critical component. It's in a lot of growth hormones. So you'll see plants that are zinc deficient will twist, they'll grow funny, they'll be stunted and short, they won't grow normally. Common in wet soils, common at low pHs. Zinc can actually go toxic. We get into 100 part per million. We don't see it in our region. Most of this is industrial mining up in Wisconsin, Minnesota. It can actually go toxic. A little zinc's good, too much is be bad. But we can see elevated zinc levels around dairy farms or old livestock farms where galvanized equipment has been allowed to rust, galvanized gates, gets into the manure, and we can see some elevated zinc. Usually not toxic, but higher than maybe desirable. So if we have less than 3 part per million zinc in our soil test, we want about 3 to 8 pounds of soil applied. 3 to 5 is sort of that maintenance range where we put just a little bit on to maintain. But if we're above 5 part per million zinc, we're good. We have adequate. But again, go over towards 100, we can actually go toxic. Manganese, this is one we're seeing a little bit more of, especially in soybeans. Had the pleasure of walking one of my own fields and discovering some manganese deficient soybeans here a few weeks ago, and it was great to look at the soil test and see that it's been there the entire time, and I've been overlooking it too focused on other things. But as a micronutrient, and micronutrient like manganese means we need very little amounts. You start looking at the soil test applications here, soil applications here, 1, 2, 3 pounds per acre. The challenge with micronutrients is applying them uniformly at those rates. That's why foliars really are a great fit. We can do a quart or 2 of product and meet those kind of application rates and do much better job spreading that uniformly through a sprayer than through a fertilizer spreader. So manganese helps split light in photosynthesis, so it splits water molecules. Again, pretty important. And when we don't have it, we actually damage the photosynthetic pathways, and we lose some of that green pigment. That's primarily why manganese deficient soybeans turn yellow. As pH goes down, the concentration goes up. Metals of magnesium, copper, zinc, iron, aluminum, which isn't necessarily desirable, those all increase as soil pH goes down. Metals become more available, and manganese is like that. So if we have a soil test of 15 part per million or less, I need 1 to 10 pounds. The lower it is, the more aggressive we get. 15 to 20 is sort of that maintenance range where we put just 1 or 2 pounds on to maintain it. Then if we're above 40 to 50, we're good. We don't need an additional. Maybe we do put a little foliar on just as a little kick, but we don't need to apply any more to the soil to try to build it. Boron is one that I find fascinating, but it's also a challenge to manage. It is key to lignin, which is part of how cells expand, especially pollen tubes. So the interest in boron as of late is we see better pollination on corn, and there's some anecdotal research that is showing that low population soybeans, we do not abort as many pods on the branches. We have less pod abortion with good boron fertilization. Boron remains soluble. It stays as an anion. It's highly water soluble, and it moves through the soil very quickly. If you apply boron to the soil as a dry material, it actually can leach out of our soils, even in Northeast Indiana, in the poorly drained, in about 3 years, 2.5 to 3 years, it will be gone. So it moves very easily. What's unique about boron is it needs hydrogen. When a plant takes up boron, it takes up a hydrogen molecule. When pHs get in the mid to lower 7s, the concentration of hydrogen declines greatly, and there's not enough hydrogen for the plant to take up boron. High pH, we can see boron deficiencies, not because it's not in the soil, because the plant can't physically take it up. Now, the challenge with boron is it takes very small amounts. It can go toxic within a couple of pound application. So if your soil test is below 5/10, a half a part per million, pretty small amount. If your soil test is below half a part per million, you need 1 to 2 pounds per acre of actual boron. That's a pretty small amount to try to spread accurately. If you have between a half and 2 part per million soil test boron, we recommend a pound in the acre of a dry material evenly spread. So sometimes folks like to go into foliars with boron a little quicker. Now, I mentioned zinc goes toxic at 50 to 100 part per million. We're not sure quite where. Boron can go toxic as low as 5 parts per million. And it's about a 1 pound to 1 part per million build. So 1 pound of boron can raise this soil test almost 1 part per million. So that being said, we run into a situation here where if we would make say we need 1 pound, if we would accidentally put 10 pounds on, somebody did a math error, we may not grow a crop for 3 to 5 years. We had a situation like this come at the lab, and it won't take much time. They wanted to raise raspberries. They made that mistake. They did a 10-fold oops. They put on 10 times more than they should have. They put 10 pounds on instead of 1. They tried raising corn for 3 years after that. And corn is more tolerant than soybeans and wheat. Corn would not grow in that field for 3 years. But once it leached through the profile, we were able to get that crop to grow again. So that's the base of the soil test. I want to go through some real quick regional trends, and we'll open it up for questions here. So what do these soil test numbers look like? This is the entire Great Lakes region that we service. So this amounts to just shy of 1 million samples per year. It goes back to 1996. And what I've got here, the bar chart, the bar is the average value. The blue squiggly line is how many of them are low or deficient. And the black line is what we call a trend line. How are those averages changing over time? So if we look at organic matter here, for example, it has been running on average just slightly over 3% pretty steadily for the past, in this data set, 23 years. If we look at it in the equation, it's been changing at less than 0.0001% per year. It's about as stable as we can get. It is showing a negative there in my equation. If you look at that y equals negative 9e to the negative 5, it's a very small number, but it is negative. But in all practicality, we're stable on average. And this is multiple states, multiple samples. So that is at least a positive. We're not, the decline has ended per se. Now we need to work on improving. Phosphorus levels. If you notice the dotted line, that's my average trend line. Our soil test levels in soil samples are declining. Farmers are doing a good job managing those. Agronomists are doing a good job managing it. If you look, though, our values, my critical level, if we go back to what I was mentioning before in our critical levels, we're looking at a range of roughly 15 to 30 is my critical level for corn and beans, a little 10 part per million higher for wheat. But you can see we're still higher than we need to be, but it's coming down naturally. And if you look at the fertilizer, the fertilizer manure applications in the region, those numbers are declining as a total. And I think this is sort of a kudos to farmers and producers, agronomists, that they're doing a good job. My little bit of concerning there is if you look at the squiggly line, those are the number of samples or the percentage of samples that are coming in low or deficient. Those are the ones that are below critical level. My concern there is if you see, and we're seeing a little bit of an uptick in the last couple of years. So that's something we do want to keep an eye on. While we've done a great job of drawing soil test levels down, we got to be careful. We're sort of seeing an upward trend in those samples testing low. I'm curious to see how that pans out in the coming years as we handle and improve our management of phosphorus. So I'll go on to potassium. Potassium, we are seeing downward decline, about a half a part per million per year. But also look at that squiggly line. I should probably have something more scientific than squiggly line. But the number of deficient samples are increasing steadily. The primary reason is if we look at our actual values, that critical range, that range that we want to keep our soil test levels in, is up here. We are actually in that range, and I did some calculations. In about 25 years, if we keep at the steady rate we are, 25 to 30 years, we will actually have the average soil test value will be deficient in potassium. So that's one that could be an environmental circumstance of the sulfur. We're not sure. I can tell you crop removal outpaces fertilizer application. So we are actually removing more than we are putting back to the soil. So that's one to keep an eye on as we move forward, is potassium. Also, if you look at some of our crops we're harvesting today, the amount of nutrient in a 220 bushel corn crop, 80, 90 bushel soybean crop, when folks can hit that, are absolutely staggering. That can be as big as some of our total fertilizer applications used to be, just to replace what was removed. And you'll find that in a lot of cases, folks, because of budgetary reasons, aren't even applying crop removal. Magnesium, pretty gosh darn steady. We would expect it's not climbing or dropping. It's declining at 0.05 part per million per year. And our dark blue line is showing that deficiencies are pretty stable. Calcium is declining at about 2 part per million, but it's also the most common nutrient we find. But if you also notice that dark blue line, the number of deficient samples are declining as well. So pH management is being taken care of, and we'll see that here. The dotted line is showing that pH is increasing. On average, we're up to 6.6, maybe a little too high. We might back that off. But if you also look at that line of nutrient average values over time, we're increasing. But if we look at the amount of deficient samples, we've been on a pretty steady decline since about 2012, 2011. We saw really probably the peak of variable rate pH management and lime application about that time. And we're seeing that result continue through. Cation exchange capacity, we would expect that to be steady, because in order to change that, we either have to add massive amounts of organic material or massive amounts of clay, and neither of those are occurring right now. And so we would expect that to be stable, but that also shows us that that calculation is stable over time. Now, some micronutrients are gaining a lot of interest. This is a bit of a concerning chart. If you notice, the average soil test value has gone from somewhere in the upper teens, where we would do just a bit of crop removal, all the way down to deficient. It has decreased approximately 65% in the past 23 years. And if you notice, the Clean Air Act was enacted in the late 2000s, right about in here, and that's where we see the number of deficient soils skyrocket. The last couple of years, we've seen a decline in those number of deficient soils as growers are starting to pay attention and apply more sulfur. It's showing up in the soil test reports, and we're seeing the response of that change in management. That's probably the most frequent change in management we've seen, has been the introduction of sulfur management as a nutrition in crop production. A couple more here. Zinc is declining ever so slightly. Probably a lot of that has to do with the fact that a lot of folks usually use a quart or two of zinc in their starter fertilizers. That's worked pretty good until we start beating and increasing over that 300 part per million, and we come into that play. Manganese, pretty well stable, not a big issue. Or iron, pretty uneventful. Copper has been declining, but that's one we usually we're still have adequate. The only one I want to get into here is boron, the one we talked about last. Again, looks a lot like sulfur. We're seeing a deficiency increase. Some of that might be due to our heavier rainfall, moving that profile out. But also, I'd argue that our fertilizers are near reagent grade today, and we're not getting the contaminants, the secondary micros in our fertilizers because of their purities. So with that being said, that's a little bit of an idea of what boron looks like. And I don't know, do we have any time for questions?
We do. So if you guys have any questions, you are welcome to type them in the chat box, unmute yourselves, ask Jamie a question. At this time, we do have a poll question coming out. So for those of you who are new, all you have to do is just click on your screen what you agree with on the poll question. And then also, if anybody has not contacted Brad or myself about their credits, so Lindsay, I'm taking care of the commercial credits. And if anybody is getting CEU credits, you also need to message me. If you are doing the private applicator credits, you need to message Brad. So we'll still be taking credits at this time. But yes, you're also welcome to unmute yourselves, ask questions, type them in the chat box. One more thing, just so we can get an idea about who all is on our workshop this evening. If you go over to the side where your name is and you click the More button, you have the option to rename yourselves. We ask that you do your first and last name. That way we can tell who's on here, who's getting credits, and that sort of thing if you aren't able to message us. Again, that is you click over your name and go to the More option and click Rename. And then that should be good.
And Lindsay, if questions come up later, I'm going to hang here for a little bit. We'll catch, if a question pops up, somebody wants to catch me in the chat, I'll be glad to address it there as well.
Perfect. All right, so we'll give you guys a couple more moments to get this, and then we're gonna go ahead and move on. All right, I see nobody typing, nobody unmuting themselves. So we're gonna go ahead and turn it over to Brad Colhagen for tonight's PARP topic.
Yes. All right. Can you hear me, I assume?
You're good, Brad.
All right, great. Okay. Had a little bit of adjustment there. I thought I would be ready, and I'm like, whoa, there's my screen and things. So, okay, well, hopefully everyone's having a good evening. We missed out on our rain, it looks like, again. A few people got it up north, which really need it. So I don't know, we'll continue. I thought earlier this week with the hurricanes, I thought, hey, it's hard to benefit from a hurricane, but we need the rains, I think, especially to help these beans a little bit long and even maybe a little bit of the corn yet. So we'll continue and hope for the best. But hopefully everyone's having a great time. I know we've had some people on this session throughout the whole three deals. I've talked to a lot of people helping them register for this things and in these virtual meetings. And so I have been impressed just with the, what I want to say, just people in general really enjoy these. I think we take it for granted. Jamie's done a great job talking about soils and soil testing and soil results. I know a lot of us just assume we know these things, and I've had so many good conversations with people. They're like, wow, that first session, there's a lot of things I didn't know about basic soils. And hey, the second one, I just learned a lot about just soil testing in general. And then I'm sure this one's the same way about learning about results and things like that and what we do with them and how we read things. And so I've had some people just even doing gardens. They're like, hey, this is good information I've needed to tap into, and thanks for doing these. And so I hope you appreciate it. I mean, this is a little bit different. I know I was even helping someone register late last night on the whole thing and said, hey, this is some stuff we just don't get day to day. And so it's pretty cool to hear that. So I appreciate ISDA. I know I've said that before, Jennifer Thumb and Lindsay and them guys just coming in and helping pull this off. And then especially, like say, Jamie and his knowledge has been overwhelming, I guess you could say, because like I say, he's just listening to him explain about pH. I know how pH is important. I know more and more soil tests I take here in the county, I'm finding that it's just not, I'm finding more our pHs are really high, I guess, in general. And so that's something that I've seen an upward trend of coming back pretty high. And so I don't know, I've tried to get answers on that. Some blame it on the greenhouse effect and not a lot of acid in the rain and that type of things. But it really does help, I think, to do a soil test and be able to figure some things out without question. So hopefully we've gained some things with that. Also, before I get started too, I try to run through my other ones. I've ran through, here are the ones that I have so far. So listen up, I'll just say your first name and maybe your last initial. Don't want to bring everyone out. For some reason, most of you I know got your name typed into the box anyway, but here are the ones that I've got down for private applicator, okay? So I want to make sure that everyone can hear their name, that some of you have chatted with me and sent this stuff on. So here's what I have so far for tonight. I have Jean K, Kim F, Sean Y, Barry M, Clayton K, Michael W, Don A, James S, Richard R, Jamie Boltemeyer, all right, Chris W, Richard M, I'm hoping I didn't call another Richard M. No, that was another Richard. Okay. And then Daryl L, James F, Kent S, and Clayton B. So I think that concludes my list of private applicators. So I thought I'd take a little bit of time just to make sure, because like I say, those are the ones that signed up in CVent. I know we've had quite a few questions over the course of this thing. At least I've helped the people. They said, hey, what's up? And if you're new to this one here, I hate repeating myself, but yes, it's $15, and I don't have, my hands are tied with that. I know, like a lot of people said, well, with this COVID thing, everything's going up, and they are. I get that. But the extra $5 is for CVent. They charge that $5 to run through all this and take your money instead of dealing with cash and all that stuff because of the COVID. So whether or not that comes down in price or not in the future, I don't know, but it's $10 it's $15 now instead of 10 for private applicators. That's just one of those things that they kind of set that bar and set that price there. And so we can't do much about it. So again, I keep getting that question. Where are we going with this? And no one knows yet. We're gonna still try to do face-to-face meetings. I know for Adams County, it's just right now we keep thinking things are going to get better, and more and more people are saying, hey, this is going to be like it was like a 1 more year thing, now 2 more years, and some people are saying 4 more years of this deal. So I hope not, but we're going to keep doing the best we can. I am trying, maybe thinking about doing, I know working with soil and water and things like that, we're going to maybe try to do a field day if things pan out. We're kind of just waiting and seeing. I know from Purdue's standpoint, they've kind of said, hey, for the rest of the year, try to do virtual programs at this point. And so that's what we've done, and especially to help the guys out that really need a credit. I know some people, like I say, for every person that loves this, this is not going to go away. I know some of you are older, and even with me, you're not just A+ into technology. I get that. And trust me, I've been nervous this whole time with this thing. It's been like, wow. But it's gone really well, at least from my end. I know ISDA's kind of shared the same thing. It's gone really well with technology, and that's great. I know sometimes it hasn't. I know we were on NEPAC's field day. I was on that here last Thursday morning, and we had a couple technical things. And so you just hope everything works. And for us so far, things have been great. So I appreciate Sheila kind of doing her part on this type of stuff too, and helping us with technology. But yes, I hate to continue going on without this, but yeah, right now it's going virtual, and this is just to help people out, get credits that really need credits. That CVent site is still going to be active. I know things change day to day, but right now that's still going on. Some have said, hey, can I tap into something else and get another credit? I'll remind you, you can only get 2 credits a year. So keep track of where you're at with things. But yes, you can tap into other field days, and there's going to be a lot of virtual programs, like the Farm Progress Show is going virtual. I've had the Farm Journal field days going on the last 3 days, and then they're having some concert thing tonight. Actually, it's on RFD TV, I think at 8 o'clock tonight, if that matters to anyone. But so there's a lot of virtual things, and like I say, where I was going was a lot of people enjoy this. The farmers, we've been hearing like, hey, I can sit in a tractor, get it on my phone, listen to a part. This is awesome. But I do know on the flip side of that, then we're not getting maybe a meal and the social aspect that goes along with that face to face. And so, like I say, this virtual thing is probably going to stay. We're tapping into more people in different audiences than we ever had before. I tried to do with mine. I made a complimentary, so you could just tap in for free if you want to listen to this, or if you want credits, then they're $15, of course. So, but we're going to still try to keep going with the face-to-face. But for right now, I don't have anything set in stone on that, and I don't know if and when that'll happen. So don't wait on that, but that helps. There is an online credit you can do, one of the 3. They still have that online version where you do a screen and answer some questions for those that need to do that type of thing too. Okay. So if you have any questions, I know I'm going to try to wrap up and go through this pretty quick here. I've got to go. Yeah, I'm trying to get my screen adjusted. So hopefully you can see my screen now. But now I've lost where I'm at with, I guess it don't matter. Oh yeah, I've got to do this. That helps. Okay. All right. So, all right. So here tonight is the PARP topic. I'm trying to look at my notes and make sure I talked about other PARPs. If you have any questions, and then some also just some homework things too. I know maybe the girls will touch on this tonight here, but to finish up. But recordings, I have gotten quite a few requests for the recordings of these programs. I'm not sure if the first one was recorded correctly, but I know I've been getting some emails on that and things like that. So if you want the recordings, I'm going to try to work on getting those. And I think, like I say, I just got an email tonight that they maybe are available. So I'll try to work on getting to those that requested them. I know some of you had sound issues, didn't catch them, and want to listen to a few more and things like that. Listen to them again. So hang in there. Email me. I got my email on there as far as that goes. Always emails me is great. And we'll get back to you and send you stuff you need or whatever as far as that goes. So, okay. Otherwise, this is pretty repetitive. I always put this slide up there. Again, each workshop we have is PARP. You have a program number. And so you need 3 and 5 years if you're a private. Again, Lindsay has applied for CCHs, and so she's taken care of that list. You want to make sure and check with her and make sure you're on that list for CCH credits. Because yes, we are supposed to turn in that CVent. That was another thing. I, at least for my end, we're turning in the CVent registration list. I know Purdue wants that. You have to pay $15, and so we're going off of that. And then yes, we're supposed to double check and make sure you have signed on tonight, and so that's pretty important there as far as that goes. Okay, all right. Okay. So the PARP topic here briefly, like I say, I got a couple slides and we're going to buzz through this. Hopefully this is kind of review for most of you. I've tried to pick some different PARP topics that I normally don't do and kind of adjust them to what Jamie's talked about through soils. And this one's more on obviously the fertilizer application regulations. Once you know kind of where you're at, different things, here are some, I know this don't totally deal with soils, but it's another step, I think, from what we've been building on. Again, some of you probably have bits and pieces of this that entertain you, and some not so much. So I'll go through this pretty quick. This has been going on since 2013. So we've been having this.
Brad, excuse me, Brad, are you intending to share your screen with us and show us slides?
Sure. That's not happening?
That's not happening.
Okay.
It should be highlighted in green, I believe, at the bottom of your screen. There,
What about
okay.
now?
Yeah, here we go.
Okay. Thanks for letting me know.
Thank you.
I guess it does say that up there. Okay, yeah, my bad then. All right. Yeah, I can, not that you missed much here. Yeah, I had that slide there at first about the program number, going over the 3 credits in 5 years, and there's my email. Okay. So yes, fertilizer application regulations. One of the things like even Jamie is alluding to, and why we've even done this, if you don't know, it's not a secret, but we do continue to have algae bloom, especially in Lake Erie, the Western Lake Erie Basin. I mean, that's been a huge thing, especially as we border Ohio here and some of the counties. Our watersheds feed into that, and so that is a big issue. Okay, there's no question. So we try to focus on around here, at least in my goals and objectives, even for next year. We're working on those in Purdue Extension. They continue to be working on trying to decrease this algae bloom. I know some of you probably don't want to hear that, and we don't want more regulation, so we're doing our best to push cover crops, to push some manure regulations and things. I know some of you do know this. Like I say, I think everyone tonight's on from Indiana here, but I do have about a third of you out of Adams County, out of state, out of county basically, and then we do have someone I think from South Dakota on here actually. So that's what's unique about this. But we definitely have an issue here, and we're trying to solve this problem moving forward. And so that's why we've kind of highlighted some of the soils and taken soil tests, not over applying. We're not trying to hammer down on anyone at this time. We know agriculture is like everything right now. It's going to take a lot to get out of this hole that we're in with COVID and the markets. It's devastating. And I know our family farm is struggling too, as far as that goes. So that's definitely an issue. So there's maybe one more slide here. Yeah, with total phosphorus. So kind of going off of Jamie's last slides there of the big picture of the Great Lakes region. I know he threw some of those up there, and that kind of complements some of the maps that I'm showing here. But those are things that we kind of want to try to fix moving forward. If you're on last week's slides, just to give everyone a little bit of a break, I threw a couple slides up here about trying to fix things. I don't know, just some creative different ideas. So I had some different slides last week, and I thought I'll kind of continue that. A couple of you said, hey, you enjoyed getting a little bit of a laugh here a little bit. So you can see here, these are all called, there I kind of fixed it. So we're kind of talking about trying to fix what we have going on with Lake Erie and things like that. I thought these were kind of creative, I guess. Hopefully some of these you've never seen before or don't have going on in your farm or your neck of the woods. But always a little bit exciting things there. Okay. And we always got our famous, like last week, we have duct tape, pictures of the duct tape. So pretty loaded down there, I guess. Surely she's not going too fast. And here's like last two. You can tell this is pretty important rocks there, I guess, to hold everything up. And then even that big them 2x4s, I'm sure, are doing a lot for that big boulder there as far as that goes. So pretty interesting. And this one always amazes me, I guess. So I'm sure he's trying to fix that light up there, and hopefully he gets her done without falling. And I'm sure that's OSHA approved there for sure. So anyway, first couple slides here, just again, this should be review. Most of you on here do have your fertilizer license, and so these couple slides again just repeat who has that, why you have it, and what is the fertilizer situation going on. But for Indiana, this is what is the fertilizer material. There is exemptions to this, and so I always try to point those out. We're dealing with organic and inorganic, but the exemptions are lime, gypsum, and biosolids. Those are not included. So if you're dumping lime in the field, which is pretty typical, we're not really that don't apply to these. Okay, so that's one big thing to get cleared up right away. Who is the exempt? I mean, they come up with this 10 cubic yards or 4,000 gallon type of deal. And I know we get a lot of people say, well, what is that and how much and all that good stuff. Okay. But yeah, the next slide here will help you out a little bit. Basically, they put some numbers to it. If you have 1 horse, okay, that will give you enough manure in a year. I mean, if you have a little pile for some reason, it's not that big of a deal, but it doesn't take, like this slide shows here, it doesn't take too many animals to produce enough manure, you could say. Okay, that these records that you need to keep and manure regulations apply to you as far as that goes. Okay. And then just to clarify again, a lot of people say, hey, do I need this? And especially those that are on here from Adams County, you know, I've tried to preach to you and tell you, just get this category 14, especially if you have a private applicator's license. Go ahead and get this category 14. There's always a lot of talk and rumor out there that eventually they're going to require this and even open it up, even if you're privately putting on fertilizer or manure type of things. And so exam has been pretty easy. It's been pretty free at the virtual sites and things like that to get it. And so it's just, it's pretty cool. I've just said, hey, go ahead guys and get it while the going's good. You never know down the road where they're going to require you to get it. So I know not everyone needs it and does have it, but that's good. I mean, it's not something extra. I don't want to jump ahead of myself on the other slide, but here is, if you basically apply or transport commercial fertilizer for hire, you definitely need it. And then basically, if you apply or transport manure from the CFOs, you need it. Okay. Especially if you're a custom manure applicator as far as that goes. Here is, again, kind of repetitive stuff, breaking it out. If you work more for the commercial side of things, fertilizer and manure, and you're for hire, no question, you need the Cat 14 fertilizer license. Okay. And then again, if you apply manure from a CFO on any property, you must be certified. Okay. Again, for hire. All right. And here you got, this was where I didn't want to jump ahead of myself. These are just showing your license. Okay. There are some out there that just have if you're a custom manure applicator, I know that's in here in this county, you just have your Cat 14 license only. It'll say fertilizer only. Okay. And you would have more of your CCH and need some commercial credits for that because you're for hire. But then some of you have both of them. You have your private there, and this fertilizer is a rider to your license. It acts like a little rider as far as that goes. Okay, so that's why we got that rider program. It's not like you need more credits. I get that question a lot. How many credits do I have? If you have two of three, then you got 2 of 3. Your PA and your fertilizer, they go hand in hand. They work beside. You don't need 6. You don't need more credits because you have your fertilizer license. If you have both of them, it's one license together. You need 3 and 5 years to help clarify that. Okay. And then, like I say, the last slides get into more of the plan and the records here and the application of the manure and fertilizer. A plan, that's pretty important. I know in this county, some people have been called out about that. This comes into play, especially if you ever have heaven forbid, a spill or an investigation or something go wrong. It's like I told you the last week, I know when we talked about record keeping a little bit with pesticides, it's not like we're looking for these things, but if you get asked, there you need to show up a plan. And this plan, again, is just, I'm trying to think of my slides ahead of time, but think paragraph here, not books, not textbooks, not a lot here, but we want you to think some things out. How are you applying your fertilizer? How are you applying your manure? Okay, Jamie talked a lot about some different aspects. You want to put your rates in there, what you applied, when, those basic things. I got some more slides coming up. but definitely think of how you're applying things. It's a no-brainer for most of us. I get that. Hopefully we think things out and we're just not, like I referred to maybe 2 weeks ago. I kind of said, I know our farm way back in the 80s, my dad was pretty cool about just opening the fertilizer gate at 1-2 inches. We're in sandier soil back home in Rensselaer, and we just spread, okay? It's a little bit different nowadays, all right? We try to put fertilizer where we need it and don't just waste money and put it on because we've always done that every year. So have a plan, whether you go off of A&L's recommendations, off a soil test. We have the tri-state, different things. I know Janie's mentioned a couple different uses there. So hopefully you've gained some aspects for that to help put that down in your plan, okay? And so always have that plan available. And again, like I'm telling you, think paragraph of how you apply things and what you're going off of to apply things with, okay? Staging, there is always questions on staging, fertilizer, manure, okay? Staging is a temporary placement of a product, and it's in a field. There's a lot of questions, and I know some people say, hey, it's not cool, we should be doing more and more on that, but it's tough to gauge this stuff in your barnyard. If you have a pile of manure and it's right outside your barn, that's supposed to be, I know, temporary. Hopefully it's not permanent, but I know a lot of people say, hey, it composts down and you can't move it and spread it every day. So it's one thing we don't typically regulate barnyard piles unless it's getting into the streams and waters and running through a waterway or something like that. So when we talk about staging, we're talking about staging in a field. So that's always important, okay? And with that, the inorganic side of things, we're talking inorganic here, so more of the fertilizer, don't place it within 300 feet of water, draining inlets, don't place it in standing water, floodway, and then like they usually say after 72 hours, you need to try to cover that and then try to apply it within 30 days, okay? And so those are some important things there I tried to mention off of that. All right, and here's a picture. Hopefully this never happens to you. All right, not a good situation. You can see that water was even higher or gone up into the fertilizer, and so that's some pretty saturated ground there, right there. So not a good spot for that to put that. All right, the manure staging, again, same thing. Don't apply within 300 feet of surface water. Keep it away, not in a floodway or in different things, and that same type of deal. You need to, we do have that issue. We get a lot of duck manure here in Adams County, even from Ohio, and they stage it. They'll, especially this time of year, they back into some soybean fields and dump it. We need to try to keep that bermed, and we just don't want the rainwaters washing it off. So try to berm that, whether you push some dirt up to it or whatever. Try to burn that pile or cover it. And like I say, the cool thing is you need to try to also keep it away from property lines, residential buildings. Can't put it on a hill, of course, with slope, and try to get that applied with 90 days. Okay, I would think here at the end of August, surely you'd be able to apply that within 90 days if you start putting them in some soybean fields now. If they were put there in June, that'd be a little bit questionable. Okay. Just a picture, I guess. Then we get into here, fertilizer material, the application of it, pretty no-brainer stuff. Again, don't apply it from a public road. If you're trying to apply fertilizer, manure, you don't want to apply it to saturated ground. Just again, some very basic things here. I feel bad for even having to mention some of that, but it's in a slide. And then we got our slides here that, again, I sent you guys an email, which I'll show you quick. Well, I guess I can tap into that real quick here, hopefully without messing things up. But you can see here that this is where we're at. You can see this on the screen there. This is a Word document I emailed to you all, or should have got it, and hopefully you do have it by now. But this is a shortened version of the rules. If you're trying to write all this down, I meant should have told you that at the beginning. Don't have a cow and try to write all this down. But this is a shortened version, and I encourage you guys to keep them in a tractor so you have them, so you know the restrictions. Print these off, and they're the very short version of your things. And so we've gone through already on page 1, we've gone through the staging, the manure side of things, the organic, inorganic, and now we're at the bottom of page 1 going through the table there, the charts. So you can see here it increases as you get to the right on that. And then, like I say, the rest of it is what we have to go for yet with the last couple slides here tonight. But I wanted to show you that you do have that, and you have all what I'm telling you, the important things in that document, okay? And if you need it again or have questions, again, always let me know, fire an email to me. But here's the blown up version of those charts. You can see there, you got your setbacks, very similar to these. Again, this is a liquid injection, incorporation, or the right-hand column there is liquid incorporation within 24 hours, or a surface applied solid. You can apply on the surface. Again, I know it's not something that's a great practice. I know I serve on Plan Commission. Part of my job here in Adams County, we continue to tell guys to try to incorporate it, work that in, especially if it's manure. It goes better for everyone involved, and we don't have stuff going down the river and down the ditch. So try to incorporate. Please try to do that. Look at the weather. It's always a good thing moving forward too. And then here's the other part of that chart. Again, if it's a surface applied, basically surface applied liquid with no incorporation or injection of manure, again, you have your setbacks, especially if you're dealing with slope. I know in Adams County, we don't have that issue a lot. So that's a good thing where we don't have slope, where we have a lot of runoff, because your setbacks definitely increase if you have a lot of slope to deal with there, okay? And then definitely no brainer here. Again, if you got really highly erodible land, which I don't think we do too much here in Adams County, but definitely you want to avoid that situation by all means. And then we got a couple slides. There's always some questions about winter application. I know go to all the board, soil and water board meetings and work with them and everything in RCS. Again, more and more, please try not to put it in on snow-covered ground. It's not a practice we like to see, but I know for Indiana, it's been a challenge trying to police that, try to say, hey, what is snow-covered ground? What counts for that? I mean, ideally, the rule of thumb is if it's snow-covered, the manure doesn't come in contact with the ground. But we do know that emergency things happen. I know, was it 2 years ago or 3 now? Time flies, I know, but we had a wet fall. I think it was 2 falls ago. I mean, there was just no way around it trying to get that manure. November was wet, December was wet. And so sometimes this is why it kind of happens. Your pits are full and you got to do something with the manure, especially. So it's kind of hard to say, hey, you can't do it. But definitely on this slide here, definitely if it's an iodine permitted, you cannot apply manure to frozen cover ground. So I try to preach that. They have that rule. If you're iodine, you have to get a special permission to do that. And to my knowledge, that isn't, might as well not even go there with them. Not going to give that to you. So just shy away from that. But at the same time, if it is some CFO manure and other manure, we do allow that in Indiana. But again, it's not a great practice. Don't go there unless you have to. I don't know how to say that more clearly. Just not a good situation because you can get some thawing and things. But we do realize, I mean, things happen, and sometimes those are the only days you can run on that ground when it's slightly frozen, it's snow covered, and it's not totally frozen underneath. But ideally, if you can even incorporate it yet, that would be pretty cool too. Okay, because here are just a couple more things, kind of reiterating what I'm saying. If the equipment can inject or incorporate the same day application allowed when the crop is not in the field, that's pretty cool. You can actually still put it at full rate. Okay, but you can see here, like when you got pretty good snow like this, If the equipment can only apply the manure to the surface without incorporation, then the following rules cover those surface only applications, okay? So you have here, these are some rules. If you can't, for some reason, get that incorporated and things, and you're putting it on snow-covered ground, definitely, again, stay away from your surface water. You can't apply within a floodway, and then you only put it on half rate of your next year's crop. You need to cut it back. You can't be putting it on full rate if you're dealing with things you can't get it incorporated in, that type of stuff. And then definitely, yeah, no brainer there, stay away from your high sloping ground, okay? So that kind of always get those questions from time to time. People call me up, see things, and so hopefully just try to do the right thing if at all possible there, okay? Again, these are no-brainer things. Always watch the weather. I know as a kid growing up, I constantly, to this day, I still do that. I know the news is not a great thing to watch, especially right now with politics and all the stuff going on. But at the same time, I'm accustomed to do it just to watch the weather. It seems like that's just something that I've grew up doing. And so you're always watching the weather, watching what's going on. So keep that in mind. You don't want to apply things right before a rain. Just not a good situation there. Use your brain. Again, your records need to be kept for 2 years. Here's a nice little chart similar to what we talked about last week, putting down your nutrient value, things Jamie talked about, fertilizer type, date, how you put it on there. The more stuff you record, the better, but keep those for 2 years at least. Okay. And yeah, to wrap up, here's just some quick little slides. Again, people picture say 1,000 words, but you can see here, this isn't a, just some pictures of things maybe probably not should be taking place. You can see here they dump some fertilizer staging there right by a ditch. So that's not a good situation there because you can't be put by a creek. It's in a waterway, all right? Here's you can see the blue mark back there. I tried to put in there, there's a blue mark for that's kind of stands for a watershed back there, riverway. And they got this stage in the middle of the field. I know it's kind of make-believe here with the corn right there, but you definitely, the pile needs to be more than 300 feet away unless it's covered. And you berm it as far as that goes like you're supposed to there. So you got to stay away from that, definitely, okay? So just kind of review slides here. Here's another one that's, well, let's see, now I jumped ahead there, okay. So they're kind of asking questions, what's the maximum time the fertilizer can sit in the field? If it's covered, you got 72. Inorganic can stay 30 days and manure for 90 days, okay? If you kind of berm it, especially cover it, all right? And then here's, like I say, then you got this, there's a shed back there, kind of make believe a little bit, got a neighbor's house in the woods, your fertilizer is there in green, and so it's kind of asking what setback distance for staging inorganic. It's definitely 100 feet from the property line to manure, so you don't need, I know it's very common to pull in a field, you want to put it right up to your property line, and that's not a great situation. Stay 100 feet away. Okay, I think it's the same question there. Yeah, all right. Yeah, and this is just reiterating the fact that 200 feet away, it just kind of review again with time. And if it was in person, we could do a lot of Q&A with these type of things, but just kind of showing you some things. If you're not incorporating or injecting that manure, you need to stay 200 feet away from like surface water. Don't apply it in a floodway, those type of things, just to review. There again, on the other side of the trees, we don't know really what's going on the other side of the trees, but you want to make sure you check that out. Stay away 10 feet from the property line, 50 feet from surface water if that's the case. Sinkholes, it's not super common to have those, but they do happen. Definitely you want to stay away. kind of depends on how it's applied, the manure, if you're dealing with manure or even fertilizer. The sinkhole category would come up with setback restrictions. It could go from 25 feet to 50 to 100 to even 200 feet. So again, stay away if in doubt. All right. And here's, yeah, no, again, this ain't going to work totally if you're going right up to there. That is a surface water basically. So you want to stay 50 foot away from that. So that's probably not going to pass. Okay, and here's something pretty typical of a picture in Adams County. We got maybe a pile of duck manure or something dumped in the field there. It doesn't appear to be burned, okay, or covered. Hopefully you don't recognize this picture. All right, sometimes I know everyone can take pictures, but I know sometimes I like to take a few and put them in my slides here, okay? All right, so not a good deal there. All right. So here at the end, pretty straightforward. Again, I'm trying to think if I think we hit on all that stuff. Very, just a good summary. Okay. And again, this hopefully isn't brand new. I thought we took about 20-25 minutes there and just kind of ran through some of this stuff. So that's pretty good. Again, these have been around for a while, so hopefully you kind of know them. If you have, again, specific questions, let me know. Fire an email to me and things like that, and we should be in pretty good shape. So with that, if there's any questions, we'll take them definitely. We got a few more minutes here, but we try to get you out of here on time, which is pretty good. That's one cool thing about staring at the computer screen. You can see the time. So it's getting close to 8 o'clock, so we'll turn it back to Lindsay.
So yeah, we will be sending out poll questions for you guys. You do not have to answer question number 1. You will see that one as a repeat. But we do ask you to respond to the other questions, and they're on your screen now. Other things, if you do have questions for Brad, you can go ahead, email him, type them in the chat, unmute yourselves. Jamie's still on, so if this question popped up in your head while Brad was talking, you can still ask Jamie or Brad. And some other things. I'm going to go ahead and share my screen. Let's see here. We have some things happening around in the district. The Soil and Water District will be having an open house on a cover crop plot that they did up on the county line between 300 East and Highway 101. And that is on Monday from 5 to 7. They're also planning a winter conservation meeting on November 17th, so just keep that date in mind. And they also have discounted soil and manure testing for Adams County producers. Brian Muster was not able to join us tonight, but he did send this over to me that if you are interested in doing programs, EQIP or anything like that for 2021, the sign up, go ahead, give him a call, and he'll get you some more information about that. If you're not from Adams County, go ahead and contact your local NRCS person. And then for the state, with ISDA, we are still offering our free soil sampling and manure sampling. This is for different areas in the St. Mary's watershed, along with the whole entire Upper Maumee watershed and the Brown Ditch and the Auglaize. So I think majority of you guys are in the St. Mary's watershed. So if you have any questions about that, if you qualify, for those that are doing NRCS 590 nutrient management and need a manure test, we do run the tests that they request, which would be the M4, I believe. So my number is on there to go ahead and contact me. If you somehow miss it, go ahead and call the Adams County office and they will send you over to me to get that answered. We do have our results coming in. Thank you so much for doing that. Jennifer, Katie, Jamie, Brad, Sheila, am I missing anything?
I think you're good, Lindsay.
Yep.
All right. All right, thank you so much for joining us this evening. We hope you enjoyed it and we hope you learned something. So check back and see anything else we have going on. And so now you guys are welcome to sign off. Thank you.
Good night.